Here we're going to start chapter 9. Chapter 9 is all about triangles, and we're going to take a kind of a review bit to refocus on Pythagorean theorem. It's kind of the foundational formula for triangles. If you remember it back from first semester, great. If you don't, well, you'll get it right here. So with Pythagorean theorem, hopefully you remember, it's a squared plus b squared equals c squared is your formula, and the c is the longest side. Okay. So if you have a triangle, A and B would be the sides that touch the 90. C would be the side across from the 90, okay? And I do want to show you guys one special case. If we have something like this, because you are going to see some problem with square roots in them, and I just want you to know how to do those. So if you have this problem right here, you're going to want to label your sides first. C is across from the 90. A and B, it really doesn't matter your order on those guys. And now we're going to use our formula. A squared plus B squared equals C squared. A is 12. B is square root 101. And then x squared for C. We know 12 squared is 144. What do we do here? Well, a square cancels the square root side. So we just are going to have 101 left by itself. Okay? So the square cancels the square root. And now we're just going to combine our like terms here and get 245 equals x squared. Now we got to get the x by itself. How do we get rid of a square? Take the square root from both sides. Boom. And square root of 245 equals x, and that's going to be like 15.7 equals x. Boom. Now if you have a calculator or if the problem asks for a thing called radical form, radical just means kind of square root form. If you punch in square root 235 and hit equals on like a TI-30 calculator, it will give you 7 root 5. Okay, that would also work. So, quick review on Pythagorean theorem. There we go. You're also going to hear a term that's related to Pythagorean theorem called a Pythagorean triple. I'm going to talk about these just briefly. These are 3 whole numbers. They must be whole numbers that work for the Pythagorean theorem. What that means is no decimals, no fractions, and no imperfect radicals. I will talk about that in a moment because we will go over some examples of these guys. And your common triples would be a 3, 4, 5, a 6, 8, 10, and you're going to notice this is just double this guy. 3 times 2, 4 times 2, 5 times 2, boom, gives you a 6, 8, 10. Another common triple is 5, 12, 13. You don't have to know all those guys, but those are triples because all the sides are no decimals, no fractions, no imperfect squares, and they do work for the Pythagorean theorem. The last thing we need to have in our notes, and we're going to use the Pythagorean theorem to do this, and we're going to use that to figure out what type of triangle we have, acute, obtuse, or right, if we're only given sides. So determining the type of triangle. Okay. So you're going to have some situations here. The most basic one is if a squared plus b squared equals c squared, you have a right triangle. Okay. You know what? One thing I need to do, I want to hop up here. Pythagorean theorem only works for right triangles. Okay, that's why you have to have a 90, and the 90 is always across from the longest side. Okay, so Pythagorean theorem only works for right triangles. So if Pythagorean theorem works, you know you have a right triangle. Okay. Now, what if a squared plus b squared is greater than c squared? Well, we know we don't have a right. If the two sides squared are bigger than the hypotenuse, you have an acute triangle. Okay. And if we go the other way, if a squared plus b squared is less than c squared, you have an obtuse. And remember, for these guys, c is always the longest side. Okay. C is always the longest side. And one thing to remember back from, oh boy, earlier, I think chapter 6, remember that the sum of the smallest two sides must be greater than the largest side in order to be a triangle. I think the problems you're going to see are not going to try to trick you, but one thing to remember is, again, the two smallest sides have to add up to something bigger than the largest side in order to be a triangle, and if that doesn't happen, then you don't have a triangle. Alright, I'm going to do some examples, so check out that lesson. Thank you for watching, and I'll see you in the examples video.